Welcome to The Climate Scientist. Let's jump straight into mastering your physics exams. Today, we are undertaking a deep dive explainer on a topic that consistently trips up even the most thoroughly prepared candidates: elliptical orbits and data analysis. Whether you're currently studying Cambridge IGCSE Physics Code 0625, or you're tackling the foundational concepts under syllabus codes 0651, 0652, 5054, or even pushing into the advanced territory of 9702, understanding how to navigate this specific conceptual area is an absolute blueprint for your success. We're going to look really closely at the raw data from past papers and dive deep into principal examiner reports to decode exactly how the grading mechanics work behind the scenes. Our goal today is simple. We want to show you how to structure your answers so you can systematically extract every single available mark. It's time to read the warning signs and avoid the common pitfalls that completely sink grades. So I have to ask, are you losing easy marks on elliptical orbits? Because you'd be surprised how many top-tier students do. To understand exactly how this happens, let's look at two incredibly common student profiles we see highlighted in examiner reports year after year. Let's call them Alex and Sam. Imagine they are confronted with a classic past paper question, something like, explain why the kinetic energy of a comet changes as it approaches the sun. 3 marks. Now, Alex knows a lot of physics, so Alex overloads the page with raw facts about the vastness of space, the mass of the sun, and the general concept of gravity. But Alex provides zero actual analysis. It's just a massive brain dump, hoping the examiner finds a right answer in there somewhere. Sam, on the other hand, is constantly rushing. Sam looks at the question, completely misses the crucial command word explain, and instead just describes the oval shape of the orbit. What's the result? Both Alex and Sam just dropped vital marks on what should have been a very straightforward question. They fell into the absolute classic trap of not reading the warning signs, and they left completely avoidable marks on the table. We are going to fix that today. You might be wondering why we are focusing so heavily on this one specific topic. Well, elliptical orbits, interpreting planetary data tables, and understanding the conservation of energy within these orbital systems, when combined, account for approximately 15% of the total marks in your physics examination. Think about that for a second. That 15% is a massive, game-changing chunk of your final grade that's just waiting to be claimed. Nailing this section is often the difference between jumping up 2 entirely different grade boundaries. But getting that 15% requires so much more than just knowing that the Earth goes around the sun. It demands that you demonstrate higher-order skills like highly precise data analysis and the flawless application of core physical laws to completely unfamiliar contexts. Okay, let's dive into this. Here is our structured roadmap for how we're going to completely decode the exam mechanics today. First, we just covered the 15% opportunity. Next, we'll break down the core physics of elliptical orbits. Then we'll jump into a practical workshop on analyzing planetary data. After that, we'll reveal the method mark strategy. And finally, we'll wrap up with the top 3 examiner traps. Now, before we continue right into the core physics, I need you to do something for your grades. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now so you don't miss any of our strategy sessions. All right, let's move right into Section 2, the core concepts of the physics of elliptical orbits. The Cambridge syllabus explicitly states you must know the distinct difference between circular and elliptical orbits, and you have to be able to articulate it clearly. In a purely circular orbit, the sun is located at the exact mathematical center. The distance to the orbiting body never changes. But for planets, minor planets, and especially things like comets, the orbit is highly elliptical. It's like a stretched-out circle. And here's the crucial geometric detail. The sun is not at the center. It is offset at one of the focal points of the ellipse. This means the radial distance between the orbiting body and the sun is constantly, dynamically changing throughout the entire orbital period. If a candidate misses this fundamental geometric difference, they might just describe a constant, unchanging circle, when the question is specifically designed to test their knowledge of the dynamic, changing nature of a comet. That's an instant loss of marks. And this offset geometry brings us directly to a truly fundamental principle of physics, the conservation of energy. Because an object in an elliptical orbit has a continuously varying distance from the sun, its gravitational potential energy is constantly changing. When the comet is out at the furthest edge of its orbit, its gravitational potential energy is at its absolute maximum. That means its kinetic energy, and therefore its orbital speed, must be at an absolute minimum to conserve total energy. As the comet falls inward, getting closer to the sun, that stored potential energy rapidly transfers into kinetic energy, causing the comet to travel much faster.
Now, how do we write this perfectly? Top students use the Peel framework. Point, evidence, explanation, link. Point, the speed increases. Evidence, the distance to the sun decreases. Explanation, gravitational potential energy is converted into kinetic energy. Link, therefore total energy is conserved. That structure is exactly what transforms a messy brain dump from our friend Alex into a perfect full-mark answer.
I want you to remember this absolutely crucial causal relationship. Orbital speeds decrease as distance from the sun increases. It is a strict, inverse relationship. Stating this clearly on your exam paper instantly shows the examiner that you understand the hidden mechanics at play. You aren't just reciting a textbook, you are explaining the mechanics of the universe using precise, targeted physics terminology. When you say this, you are transforming raw, disconnected facts into a sophisticated analysis. If you see a question about cometary motion, this inverse relationship needs to be at the very front of your mind.
Let's transition into Section 3, Analyzing Planetary Data. Knowing the theoretical physics is only half the battle. We really need to see how these theoretical foundations apply when you are faced with a wall of raw, intimidating exam data.
Okay, time for an interactive challenge. Imagine you're in the exam hall, the clock is ticking, and the examiner presents you with a massive, complex table of data. You've got about 60 seconds to make sense of it. There are 5 specific variables candidates must be ready to extract and interpret on the fly: orbital distance, orbital duration, density, surface temperature, and gravitational field strength. Let's do a visual data scan right now. When analyzing a planet's distance from the sun against its surface temperature, your primary goal is to scan for the core trend. Obviously, there's a general decrease in surface temperature as orbital distance increases. But wait, scan closer. Did you spot the anomaly? Look at Venus. Venus is actually hotter than Mercury, even though it's further away. Why? Because of its incredibly dense, carbon dioxide-rich atmosphere, causing a runaway greenhouse effect. It is this exact level of highly nuanced data extraction, spotting the trend, and immediately identifying the anomaly that demonstrates true grade A application of the concepts.
True mastery in this exam requires extracting data, interpreting causal relationships, and crucially, integrating these facts with entirely different areas of the syllabus. If a question on planetary surface temperature can be connected back by you to thermal physics, specific heat capacity, or infrared radiation absorption, it shows the examiner a brilliant, holistic understanding of physics. Principal examiner reports continually highlight that candidates who reference these cross-topic connections achieve significantly higher marks than those who keep their knowledge in isolated boxes. And hey, stop scrolling for a second. If you want to build these cross-topic connections easily, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 whole grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Awesome. Let's keep moving forward into Section 4, the Method Mark Strategy. This is the exact procedural framework, the blueprint we use to systematically secure points for the analytical process itself, even if you mess up the final calculator math. The method mark strategy is an examiner scoring system where marks are awarded for demonstrating the correct analytical process and showing systematic working. Here's a secret. In Cambridge physics, the final numerical answer is very often only worth 1 single mark. The bulk of the marks, they are awarded for your methodology. Let's do another quick challenge. Find the flaw in this sample paragraph from Sam. The planet takes longer to orbit because it is further away, so the time is bigger. Did you spot why that loses marks? It completely lacks specific physics terminology and shows absolutely no systematic working or reference to equations. It is way too vague. An examiner will give that 0 method marks, even if the general intuition is somewhat on track. We have to be better than that. So, to build a truly bulletproof process, there are 5 exact steps you must follow to secure every single method mark. Step 1. Deconstruct the question and decode the command word. Is it asking you to describe or explain? Those require vastly different answers. Step 2. Extract relevant data from the given tables or text. Step 3. Select your analytical framework, like the Peel method we talked about. Step 4. Execute with clear mathematical notation. Always write down the base formula before plugging in any numbers. And Step 5. Present the final answer with correct terminology. Instead of writing a vague phrase like, gravity pulls it, use precise, examiner-friendly phrasing like the gravitational field strength exerts a centripetal force. If I give you 30 seconds right now to speed write a perfect Peel paragraph using these steps, could you do it? Practice this sequence until it becomes second nature. Let's look at the overarching deconstruct, solve, evaluate sequence. This is an essential lifeline when you are under pressure during the exam. Top-scoring candidates don't just mindlessly calculate a number on their calculator, write it down, and move on. They always stop to check for reasonableness. For instance, if you're calculating the orbital duration of a newly discovered comet and your math yields an answer of 3 seconds, you need to pause and evaluate. A comet doesn't orbit a star in 3 seconds. Questioning your own assumptions, double-checking your unit conversions, like days to seconds or kilometers to meters, and evaluating alternatives ensures that you absolutely do not drop simple, silly marks due to a panicked calculation error.
Which brings us perfectly to our final section, Section 5, the top 3 examiner traps. These aren't guesses. These are direct, strongly worded warnings pulled straight from Cambridge principal examiner reports about where candidates consistently fail on this specific topic.
Let's break them down. Trap 1. Using the wrong analytical approach for the context. If the question is about an elliptical orbit, do not use the standard formula for constant circular velocity without explicitly explaining that you are calculating averages, because as we know, the speed of that comet is constantly changing. Trap 2. Forgetting format and presentation. Messy, chaotic working out means examiners literally cannot follow your logic to award you those precious method marks. Use a time management matrix to allocate enough time to write neatly based on the marks available. Trap 3. Providing answers that are not specific to the given context. If the data table provided is specifically about Mars and Jupiter, your written answer must explicitly reference Mars and Jupiter and quote their data. Do not just talk about general planets in space. Context is king. And here is a massive examiner alert. The reports reveal that candidates consistently, year over year, confuse key physics terminology. They carelessly mix up mass and weight. They confuse an orbital duration, a year, with a rotational period, a day. And they incorrectly interchange gravitational potential energy with kinetic energy when explaining orbits. The absolute best practice here, the cheat code for your extended responses, is to always explicitly define your terms right at the start of your paragraph before using them. It creates a rock-solid foundation of clarity that examiners absolutely love and readily reward with high marks. When you're studying this week, one incredibly helpful memory hack is to create a custom acronym for the 5 planetary variables we analyzed earlier: distance, duration, density, temperature, and gravity. Something simple like "don't drop down the gap" works perfectly to lock them into your brain. Writing a quick mnemonic like that at the very top of your test paper the exact second the exam begins serves as an excellent visual checklist when you are inevitably asked to analyze a complex data table later in the paper. Now, students who implement these physics strategies and frameworks see an average improvement of 2 whole grade boundaries, but that only happens if they practice consistently with our weekly explainer sessions. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at AceTheExams_IGCSE and click that bell. Don't let another exam pass you by without being totally prepared.
So I'll leave you with this final provocative thought. Have you truly mastered the conceptual connections needed to excel in completely unfamiliar contexts? Mastering this syllabus isn't just about memorizing disjointed facts about space like Alex did. It is about evaluating raw data, understanding the underlying conservation laws of the universe, and communicating that knowledge with absolute mathematical precision. I want to hear from you. Drop a comment below with your target grade for physics and tell us the biggest single challenge you're facing right now. Our team responds to every single comment to help you out. Make sure to like and share this video with a study partner who needs to see this. Ace the Exams. Your Cambridge success starts here. Keep learning, keep analyzing, and I'll see you on the next explainer.